Hello, welcome all of you. Welcome to this session for Architecting for Resilience. My name is Varun, and I'm a co-founder of a company called TechTrade. We are an enterprise service mesh company. And in this session today, I'm going to talk about resiliency and to be more precise, runtime resiliency and something that is built into your network. So, but before we go there, just some context, and I'd like to start any given uh, talk or about a technology topic from history. So, Cloud 1.0 was the first era of cloud. It was when we saw the wave of virtualization and people basically getting more out of their hardware, and uh, that went on for quite a few years before we hit the era of current cloud, which is Cloud 2.0, which is basically getting cloud resources from compute resources from someone else. So you don't have to run machines and data centers and someone else and running them for you more efficiently. And you swipe your credit card and get resources that they're managing. And that has helped tremendously on provisioning agility and bringing up compute anywhere we want. But really where we are going towards is Cloud 3.0, which is a more dynamic and distributed compute. So dynamic in the sense of um, uh, containers and auto scaling and scheduled through orchestrators like Kubernetes, and distributed in the sense of um, different regions, private public cloud, hybrid, and so on, as well as distributed in the sense of application components being distributed. So in a world where compute is so dynamic, our networking and security stacks are the ones that are lagging behind, and those are the ones that need to catch up. So prior to starting TechTrade, I had the opportunity to work at Google for about 11 years. And, a lot of people talk about how come Google infrastructure is so reliable and secure? How come it's so resilient? And despite launching more and more services, despite having, thousands of new developers join every year, the infrastructure is always up and available. So one of the core to that is the investment in the core network, and networking innovations at Google have been quite a few. Not all of them have been talked about, but I was on the front row seat of the last two, namely JRPC and Istio, both of which I was a co-creator for. And those are where the networking stack was taken to application level. So really making the networking application aware. So JRPC, as some of you may know, is this modern RPC fabric, and was launched in 16. And Istio, which is this proxy-based approach, injecting proxies into the network and making them L7 proxies, which are aware of what is going through them. And this was launched in 17. And both of these are thriving open source projects today. So coming back to the context of this talk, resiliency is super important. As more and more companies are moving to public cloud, anytime there is an outage in any of the cloud providers, the list of brands that are affected it just keeps going longer and longer, right? And that significantly hampers their uptime, not just uptime, but their business and their brand image. So how can we do better? Well, before we go into that, let's just scope the problem of resiliency. It's a multi-layer problem, which it can start at infrastructure layer, but then extends to the network layer. And the more distributed they are, the more critical the network layer for reliability. And obviously extends to data layer as well, and to your people practices and operations as well. Right? So failures could be of different types. You could go from like, a host to a node to a given service to a given data center to a given region, and obviously to at a physical level in terms of cabling and uh, uh, switches and routers as well. So all of these can cause failure modes in and availability issues for your applications. The question is, how do you design your applications to be resilient against them? And can we do better than just like two deployments, active active or active passive? So in a world where compute is becoming available everywhere, my stake is that you should be deploying applications in multiple zones, multiple availability zones, and they're easier now to provision, run, and manage anyways. Deployment pipelines are more automated. So all we really need is a smart connected network which can route traffic to the right healthy deployments all the time, and we will have resilient applications. So easier said than done. How can we actually do this in practice? So let's look at some scenarios. So let's imagine a simple scenario of a three-tier application. You have your front-end web server database, and you have traffic coming into some sort of edge. It could be, a data center or a cloud region, then to some sort of a application proxy or an ingress proxy, and then into your application. So first thing is the application should be deployed in multiple availability zones. So that's like the first premise of making it more resilient. The second is simulate faults and harden your service code base against the ability to handle faults. And things like Service Mesh and Istio have certain capabilities where you can, inject and simulate faults and make it ready for make them more fault tolerant. So once you have applications deployed in availability zones, the thing that you need is for it to have failover is connectivity between the zones, so you can actually have route traffic over. So those are some good practices to do to improve availability. Let's say you have a specific service instance down on a given node, right? Could be database, could be web server, could be front end. Just take one. So the approach in this resilient network is to have a service proxy next to each service, or an application proxy in front of the entire application, which can detect that a given instance is misbehaving. Maybe that can be detected through higher latency or higher error rate or some other signal that is coming from that instance, and is usually coming from the sidecar proxy running next to them. And that can signal to say, okay, I should be routing traffic to load balancing to a different instance, which is healthier, which has healthier compute pools, which has a healthier, pods, if you follow Kubernetes. And that is an easy way to keep availability and resiliency. The other is about failures will happen. So how do you actually um, make sure that the proxies are smart enough to have uh, timeouts built in and quicker retries built in so they can recover from those modes. So those are good tips and practices as well. Let's say the entire service is down and none of the instances is actually available in that given zone or in that given data center. Well, what do you do then? Then what you need to do is is route to a different availability zone. Um, and it's easier said than done. So for that to happen, you need to know the state and health of each of these services and all of the zones in real time into a controller that can then decide, okay, where should I route traffic? Um, you need connectivity between them for uh, for it to actually be able to route traffic. You need to data consistency is a whole other layer of problem that needs to be solved for you to have consistent outcome. And the other is it is always desirable to have these running on auto scaling infrastructure, so um, resource capacity doesn't become an issue for our availability. Now, one thing that we all know, but sometimes it's forget, and it's good to put it in numbers, is what is availability? Availability is defined by how much is my average downtime in any given year. And we often talks about like 2 nines, 4 nines, 5 nines availability, but really just having it available even from 1 to 2 availability zones significantly decreases our downtime and improves our resiliency. So having it even from 1 to 2 is a very meaningful impact. Now, continuing this trend, let's say instead of a service or a service instance, it's the entire application is down, and how do you then route traffic to a completely different instance of that application, and how you need to set up a two-tier load balancing such that the the layer above it, in which case the edge proxy can actually know that which application proxy to send traffic to. And here what's important is all of your other security controls, compliance controls that you have built in that you need to operate the application are actually available in all of these availability zones. And that's something which is done through configuration in service mesh and these L7 mesh-like architectures, which can then make sure that same configuration is shipped to all of them, and therefore you can guarantee sort of same behavior. Now it's easy to on this diagram, but not easy for everyone to achieve the setup such that health signals are propagating to edge proxy is making the right decisions, and you are load balancing in the correct way. Now you can elevate this problem to not just one application, but the entire region is down, entire data center is down, or is out of capacity. And in those scenarios, you want to route to a completely different data center. And in clouds setup, it could even mean to a completely different cloud as well. So as long as you have the applications deployed in these zones, the problem solution is similar, which is you have a layer above which has the signals for its health and performance at any given time, and can make routing decisions and route traffic to optimal zones, and then from there to optimal application instances, and from there to actual services. So in summary, I think my main point in this talk is that I think we're moving towards a world where we can have this dynamic auto-scaling application-aware network. And the reason to call it auto-scaling is we can run all of these load balancers can also be run in a compute which can auto-scale, and they can be elastic as well, just like your compute nodes. And this setup, if deployed properly, architected properly, can do two things. One, significantly improve your application resiliency, and two, not overload your developers to have to build all of that into each of their services and applications, and make it more a part of the network fabric itself. So, we at Tetrate do this for a living. We have a platform that enables this, and having done that in a bunch of places, we have quite a few of best practices and blueprint architectures that fit well in actual real environments. With that, thank you so much for listening to me, and I'll be happy to take questions.
I was taking like many notes during presentation, and I think the first thing that came to me, like while you were going over that, let's say the story of network evolution at Google, what came to me is like what led the creation of JRPC in Istio? Like why was like what you had before wasn't optimal that then led the creation of then JRPC in Istio? Like, so what problem wasn't being solved? So if maybe you want to touch a little bit on that. Thank you.
Yeah, sure. Yeah, so JRPC is the next rendition of something called Stubby inside Google. Stubby was there since beginning of Google, which is like 1999, and really it was any two services can talk to each other via this Stubby mechanism. So it existed for a long time, went through like bunch of iterations over like maybe 12 years, and then the reason it's needed was so twofold, right? So at that scale, like if you do JSON over HTTP, which was the classic way of doing it for client traffic, it wasn't optimal enough for our scale. So just to give you some examples, right? If you just by doing protobuf, which is binary over wire, then text over wire with JSON over HTTP, you get like 10x improvement in many scenarios, and that meant like millions and billions of dollars for savings at our scale, right? And then gradually, what happened is a lot of things got built into Stubby itself, like load balancing, like retry, sending out some of the spans for tracing, and so a bunch of stuff happened in that. And so JRPC was nothing but the next version of it, which was got open sourced, right? So now the reason is in one organization, you can be very opinionated and like, okay, I'll just do support 3 languages or 4 languages, in some cases only 1, and then these are my libraries, and JRPC is library based. So it was okay, but when we were putting it down there in the open, you cannot have that one organization opinionation, right? So Google practically runs in 3 languages, and C++, Java, Python, and then everything is in that. So when we had to go into polyglot world, and that is and also support a lot of like existing services. That's why the need for like something which is not library based and proxy based, and that led to sort of Istio.
Which is a question by Eric here on the chat. There's a debate that for circuit breakers, this is preferred to avoid dark powers or retries, and typical thinking is that they need to be implemented at the application and not at the network layer, right? I think you sort of addressed a little bit of this, but like your thoughts?
Yeah, I'm reading his question too. I think they need to be implemented application. Yeah, okay. Yeah, so there is this interesting times that we are going through in terms of what is in application, what is in network, and this and in many cases there needs to be cooperation, right? So and like the taking the for tracing, for having the passing on the header values, etc. That's a good example where you sort of have to do it in application. The circuit breakers, I mean, the core proxies, be it Envoy, be it other proxies, they have these sort of concepts inbuilt in terms of the ability to check health of upstream. Envoy calls it upstream, like wherever you are sending it to, and defining the rules of when I break it, and doing all that via configuration. So that those paradigms exist in these proxies and control planes. Obviously, the health. This is all based on proxies only know based on all the traffic that's sort of going through them, and in terms of the latency and error rate of sort of the request going through them. They don't know other aspects of your underlying compute. Let's say your CPU is overloading, your memory is going, like the that application is consuming, that won't be known. But what is happening more and more now is and there's somebody asking for questions of like what does tetrate do and stuff. So some of these things are getting added on, which is like passing on the signals of let's say from your cloud from your node of like CPU memory signals, and those being passed on to make some of these decisions, or being able to take external signals from application to let the proxy make decisions, right? So but obviously application itself has like the most context, but how much are people actually developing that in terms of understanding all the way from node all the way through like different things that could go wrong? I think that's hard. So the thing we are at least seeing more and more is sort of the two things: interaction between the proxy and the underlying node and application, and also the reverse. So which basically means that proxy signaling to the underlying auto scaling infrastructure to scale, right? So that actually is also happening more and more. So I know that the health is degrading because of latency going up. I signal down to the auto scaling infra of somebody like Kubernetes or just the cloud providers like Instance Group, and that's a signal that is not being used and should be used. All right, I see
another good question here. I think especially for you that worked at that is heavily involved, but there is the perception that Istio is not being fully adopted at enterprises. So what do you think? Let's say maybe expanding a little bit of the questions, like what are the things that enterprises need to realize to then take advantage of, as you call this, smart application aware network?
Right. No, it's a very valid question. I mean, it's Istio took on sort of marketing momentum before technology momentum, and that was kind of the reasons of its feedback loop. But it's gotten better now. It's gotten a lot better now. The other thing is it's you have to it has too much of too many knobs and too many configurations and so on, and it sort of just makes it complicated for people to grok and adopt. And so the other thing is you need like very very clean controls on who can do what. I often tell people, like, unlike Kubernetes and other things like that, like Istio is and service mesh in general is like a multi-persona problem. It's not a single persona problem. And how does the actual inside an enterprise, how does a platform team manage the gateway, manage the sidecar? And sidecar is usually coupled with application. So now, how do you do application upgrades? And that is for the app team. Gateways are usually managed by a different team. If you're going all the way to edge, there's like usually edge and edge proxy teams. And then security wants to always be there as like somebody who's at least having visibility, but in many scenarios even wanting to enforce what policies have to happen and what is optional to happen. And they even want to be in the workflow of exposing a service to outside. So the net of that being basically, you have to solve for what does each team get in terms of their views and controls. How do you make the knobs just simpler to use? There's too many knobs or too much YAML, if you ask me. So one thing is like, just make it simple to say, these are my this is my API, this is the behavior I want, and that should just happen. And sort of things like Istio are just there in the platform to make it happen and in the infrastructure, right? That's kind of the approach we have taken at Tetrate. And I think that's a long-term way if this is to be adopted for real at scale and for a longer time. That's how it will come to be. Like most technologies, it will become boring and not visible, and there'll be a way to just use them and not have to sort of tickle with the details of them.
When we talk about service mesh and then let's say Istio and of course other technologies, there's always that concern on how does that relate to traditional API gateways, right? That the lines, they get blurred, it gets a little bit fuzzy, like what is an edge proxies, what is an API gateway, and this, like, are they different? Should they be different? So like, what are your thoughts on this?
Yeah, I mean, I'm obviously biased here, but I think they should not be different. And the platform we are building and built and deployed is like, use Envoy throughout, as you can deploy it as a tier 1 load balancer, as an edge proxy. You can have each application can have a proxy and an application proxy at front, and then you can have sidecar, which is also based on the same data plane. So one data plane throughout, and then each application, an application being a first-class concept for us, doing like what it needs to do, right? In some cases, you like, I just do authentication at the ingress layer, and that's all I want, and that's all I need to do. I'm not going to go into sidecar business for a while, which is okay, right? And whereas someone else would want to, like, no, I'm ready, it's all HTTP and I'm comfortable. It's not like super performance sensitive, and the latency stuff is not concerning to me. Is you can go down that path as well. So, but to your question, I think the way I think about it is people build services, people deploy services. You can expose them to to your internal teammates and or your partners via internal APIs. You can expose it to public via public APIs, and but controls you need are similar. And I think that's so that line is sort of blurring between sort of traditionally what used to be like north south and east west, right? People do more microservices and API contracts. You need internal API based interactions, and the only difference is internal APIs you're doing, let's make it real, right? You'll do token based authentication there, and in external APIs you will demand for, like, oh, I need to have OAuth and you need to go through this flow. External APIs you'll do like, no, I want WAF style policy of like bulk protect against type these set of IPs, whereas in internal APIs you will just say, oh, test traffic from this team should not DOS me, so just rate limit so scenarios are a little bit different, but controls at the technical level are similar. I think it makes a ton of sense to just have it in one platform, and that's the only difference. Between so in fact the team that Istio came from, it's ironic I use that word, was actually called One Platform, which was Google's way of saying this is internal APIs, external APIs, it's all sort of under, you just tell us what you want in your APIs, these are the behaviors. All we used to do as a team in Google was that every team would just submit their API spec and what they want, and things would just happen. And today it's an internal, tomorrow it becomes an external API. You could just sort of append a few things on that API spec, and that's it. Nothing else changed in terms of rolling it out. Sorry, I don't want to keep going. I know more questions are coming.
No, there is I think the mesh of meshes, if it's if that's a thing or not.
Yeah, the term I don't really like, but the concept is really true. So what we do at Tetrate, and I think more generally in industry, it is becoming true, which is you need to have, there are three sort of layers in this, and this has not been explained that well yet. There is data plane, which is like has to be close to where it has to be right where the traffic is. There's a control plane which needs to be in the vicinity of it, which is in the same cluster or same VPC or some but not too far. And then there is sort of a third layer, which is what we call management plane, which is sort of where you look at the top and say, okay, what do I need to do across for each of the applications across, and do routing decisions and resiliency decisions and so on. So we believe in that world, and we're building sort of the management plane. But Istio is still used as is, and as it's growing in features and all that, as the control plane in vicinity, and absolutely having it be done in a way that it's agnostic of compute and cloud. So if I have n clusters in let's say Microsoft Cloud, n clusters in Amazon Cloud, each of them can have Istio as the control plane. But then how do you actually make, and someone asked for this I think above, which is can you really make those kind of resilient decisions of, okay, instead of routing to this Microsoft zone, route is to this Amazon zone. And that decision could be, people have come and asked me for can we do that for cost, performance, security, or whatever other service that they like in that cloud region. And that absolutely is something that is possible, not super easy for people to achieve. We want to make that easy to achieve. So Rishi, to your question, I think we are going towards that world. Mesh of meshes sounds like a bad name, but architecturally we are going there.
Thank you. I do have another question here. Is it so? Can we?
I'll just finish. Sorry, he has a follow-up question. Sorry, Dio. Yes, it can sit anywhere. That's sort of the beauty of the management plane. You could, it could be in any of those, wherever you decide it to be. The thing is, the required edge or ingress is to be placed closer to where its application is. Yes, that's what it is.
Thank you. So I like the smart application network aware term that you have. Do you think can always be automatically equated to, let's say, service mesh in general? Or let's say if I'm not to use, let's say, an edge technology for this, what's my alternative then, if any?
Yeah. No, I think it's not just service mesh sort of became this everything term, but I actually like the concept is that your network and your platform layer is smarter. And today we have so for example, JRPC, which is my other baby that I had, is supports XDS. So you can just build stuff in JRPC and not have any proxies, and ask for the same behavior from control plane, and this all works And I think more and more language stacks, more and more frameworks will start supporting these XDS-like capabilities. And once they do that, I think we can go into how things are built itself. It hasn't happened yet, but that I think is what should happen. And it's not just it could, today is Envoy proxy, tomorrow could be something even better, but the concept is the same. Both in language frameworks and in these proxies, I have them make them more intelligent so that you're not doing it in application, and you can do that consistently without loading up the application developer across your fleet. I think that concept is very, very, very useful and here to stay.
Cool, thank you. Thanks, Varun. I think it's we're going to switch now to the speaker breakout room. So the link is on the chat. So there we'll have more like an open opportunity for all of us to chat. We can all turn on your cameras and audio to interact directly with Varun. So I will see you in the speaker the Hangout Zoom in a couple of minutes. Thank you very much. Thank you, Varun.